This video is for Perfect Squares Intro and Perfect Squares. I'm looking at Perfect Squares Intro, and I have this example here. There is a poster on the wall that says u squared plus 2uw plus w squared equals u plus w. It's at the bottom of the poster times u plus w. And when we were doing this, I coached a lot of you to just use this template. You can also think of it in terms of an area model. If I have 81 plus 18x, I'm going to put the 81 here just because we usually did that with area diamond. We usually put the first term here, but if that's throwing you off, you could just put x squared here and 81 here. So I'm looking for factors of 81x squared that add up to 18x, and that would be 9x and 9x. So you don't have to do area diamond. In fact, I hope that you are starting to see these patterns and saving yourself some time. But if I were doing this, it would be 9 times 9 and x times x. 9 times 9 is 81, x times 9 is 9x, here's another 9x, and here's x squared, so that would factor into 9 plus x times 9 plus x. And many of you, I just coached you and said, okay, if u squared is 81, what's u? And you chose 9. Or if x squared is w squared, what's w? It must be x. The only thing to be careful about on these is if you get one that has a minus right here, then these would just both be minus. And the nice thing about this pattern is you can always, just like difference of squares, you can just check it really quickly and make sure you did it correctly. You don't have to do the whole area diamond piece. Okay, the next question says 1 plus 2x plus x squared, and I'm supposed to find the side length of the square. So I'm only going to write one side length, so be careful on that you're not putting in the whole thing. If you think of this in terms of an area model, you have 1 and x squared in opposite corners. So to get 2x, you know it's got to be 1x and 1x. You don't really even have to do area diamond here. Or if you just use the template, if u squared is 1, u is 1. 1 times 1 is 1. If w squared is x squared, w must be x. So this is 1 plus x times 1 plus x. Okay, now I'm looking at perfect squares, not Perfect Squares Intro, and I have 9x squared plus 6x plus 1. So that is in the form u squared plus 2uw plus w squared. So I'm going to use my template. I know that's going to factor into u plus w times u plus w. So this, if u squared is 9x squared, u must be 3x. And if w squared is 1, then w must be 1. So it factors into 3x plus 1 times 3x plus 1. Easy to check. 9x squared, 1, 3x, and 3x. If I add like terms, combine like terms, I get the 6x term. Okay, so a lot like the difference of squares exercise for perfect squares, they're going to give you ones where, yes, it can be done with area diamond. Actually, I don't think you could do this with area diamond because this, you'd have to factor out that 2. So that would mean I'm going to, divide everything by 2. So if I divide all of these terms by 2, that would give me x squared minus 20x plus 100. So what I'm doing is I'm factoring out the greatest common factor for these three terms, which on con has been every single time the coefficient of x squared. Now this is a perfect square trinomial. It's in the form minus 2uw. So that's going to factor into u minus w times u minus w. So then this would be 2, that 2 doesn't disappear, times x. If u squared is x squared, then u must be x. And then if w squared is 100, w is 10, so that's going to be 2 times x minus 10 times x minus 10. Easy enough to check x minus 10 times x minus 10. When I combine like terms, these would add up to negative 20x.